Now, I want to talk, this is almost a talk within a talk, so we're going to be glossing over a lot of things and going very fast in this section, I'm sorry. Otherwise we'd be here until sunrise and tomorrow on these topics. But there's things you need to do to Zend Expressive to make it a fully functional API service. So the thing I like about Zend Expressive, hopefully I've shown you that it can give you a solid foundation for building out an API. But there's lots of things missing. It doesn't bill itself as an API, as a ready-made API service that you just drop in some end functionality and off it goes. It doesn't bill itself like that. It's a framework that you can then build APIs on top of. Excuse me. And the nice thing is, most of what we need in APIs can be built by dropping in some middleware, which also means we can reuse it. Yep. Because they're isolated, once we've got it working for one client, we can take it and use it elsewhere. And there's a couple of things where we actually want to put some services into the DI container because we want to expose those everywhere. And the first of those is logging. I went up to PHP Northwest, or I guess from your case down to PHP Northwest, sorry. I live in South Wales, which is it's not the other end of the country, because that would be sort of Cornwall, but you know, it's pretty south. Pretty much, yeah. So I went up there earlier this year and I did a talk called Designing for Disaster and explaining things you need to do to an app, whether it's an API service or a web app, to deal with when things go wrong. The slides are online. Assuming I've not used a dodgy QR code, that should take you to the slides. It was also videoed, and all my videos are online. My infamous video backlog is completely gone. There are no videos left in the backlog at all. Only took a year to get through them all. There's 40 videos up online now, so it was quite a backlog. Yeah. But that will explain where I'm coming from with logging, so I don't want to repeat all that here. But the fundamental premise is you can't use something like Xdebug in production, so you shouldn't be using it in development. You've got logging in production, so in development, in order to understand your app, debug it and get it working, you should be using the same approach in development and prod, so that when you have to troubleshoot in prod, it's the same process. You've practiced it over and over, you've built up that habit. That's the basic idea. So logging to me is very important. So how do we add logging? First of all, you've got to register a logger with the DI container, so it can be served out everywhere. Whilst it's tempting to ask for instances of monolog, for example, or any other logger, use the PSR interface and ask the DI container, give me an instance of that. And that way, it doesn't matter what logger you use today, tomorrow, next year, 5 years' time. The logger can be changed, but as long as it's compliant with the interface, everything's still going to work. Again, we're trying to reduce dependencies on specific things. That said, I'm going to contradict myself here deliberately. Use monolog. Absolutely use monolog. The reason for this is a DI container, you can't change. Once a DI container is created a logger, you can't tell it, oh, I want a slightly different logger, as you want to add more information to that logger, you see. You can't create a new logger with extra metadata and put it back into the container. You're stuck with what's in there. And so we're going to want to mutate that logger because in our logs, we're going to want to add more information as we understand the request better. We want to know things like who the user is, for example, and I'll show you more about that as we go through. Monolog today allows you to mutate it. I know they're doing a rewrite at the minute. I'm really hoping they don't take that feature away because immutability is a bit of a trend. But an immutable logger here is absolutely sodding useless. Absolutely useless. You need to be able to change that logger because we are going to be gradually adding metadata fields in monolog terms are called extra fields that are going to appear in every log message that's written out. The reason for that is a bit like when you add indexes to databases. We want to find relevant information as quickly as possible when we do searches. So we want to have common keys everywhere in our logs so we can pull up all the related logs in one go. That's what you want them for. Yes, you're making your logs bigger, but believe you me, when you go into your logs to troubleshoot a production problem, you don't care. You want to be able to find information fast and you want to know you've got all of it. And that's what this is all about. One thing you want to do is add a UID extra field or metadata field that's generated for every API request that hits you. So that you can find a single API request and isolate all the logs messages about it. That's what you want to do. Monolog has support for this. It's crap, don't use it. It does not generate IDs that are unique enough, unfortunately. So you'll need to write your own, I'm afraid. Sorry, Geordie. And then once you've got this, you're going to start using it first of all in middleware. And the first thing I do is I write a piece of middleware that logs all the requests coming in and all the responses going out. Now you use different log levels, so this for example I'd probably set as debugs because I wouldn't want it switched on 100% of the time because your logs would be gigabytes, which would drive everyone nuts. But it's handy to have that feature built into your API from day one. So it's going to do this, and it's also going to do some of the mutation as well, because the middleware is the first time we've actually looked at the requests coming in. And one of the things that you'll see is, are you familiar with the concept of a request ID header? Yep. So for those who haven't, if you're working on what's called end-tier architecture, where you've got a front end that does all the presentation and it's calling out to a back-end service, sometimes called a service-oriented architecture, which then mutates into microservices, which is just like slices of pizza everywhere. Yep. A common way to trace a piece of functionality all the way through that distributed architecture is, for whatever's at the front, is to add a header on its internal requests called request ID, and you propagate that everywhere. It's a common solution. It works really well, because if you're collecting all your logs into a central log aggregator, once you've found your request ID by finding a relevant log message via other means, you can then just do a search for that request ID and see everything that's happened. Really handy for understanding what's happened straight away. And other pieces of middleware are also going to mutate the logger. They're going to add extra metadata. In the authentication middleware, once you know who the user is, you want that in your log message. Because, I don't know about you, but if I get a support request, it's from a person who's tried to do something and has had a problem. So I'll often start by searching for what that user has done, and then I'll switch to some of these other things like the request ID or the unique ID for the request in order to isolate out what's happened. But the user ID is normally the first search term I'm using, you see. So that's very important. So that's logging. Error handling. Now, the first thing we want to do is actually have a common format for all our errors that come back. How many of you have used APIs where every request response is different? And it's an absolute pain to support them and deal with them. Yeah. So commonality makes life easy for the people using your API. Big shout out to Rob Allen on this, who pointed me at RFC 7807, which is a standard for doing this. We don't need to invent one. We can just use this. It's very simple. It's very straightforward. So first thing I do is I write some common code to do all this. Now, the next thing is, how do we get these errors in the first place? It's handy to have an exception that's thrown, or a library, or a tree of exceptions for this. So I introduce what I call an API error. And via callbacks, I can inject this into my business logic. And I'll explain what I mean there in a moment. When a business logic throws an exception, the response is actually built there and then, because I know exactly what has failed and why, and I don't need to massage that message, etc. I want that message to propagate up and out. So I actually build the HTTP response there and then and let it propagate out. And that works really well. Now, I mentioned about injecting error handlers into business logic. Last year I did a talk up at Edinburgh, down at Edinburgh, sorry. You're going to have to live with me for that one, I'm really sorry. I've been here most of the week. You think I'd have clocked by now. About 5 patterns to improve application robustness. It is about a 2-hour talk, I'm afraid, but go watch it, and it'll cover the concepts that I'm using here. Now, once we've got these exceptions flying around, we need a try-catch block somewhere to deal with them. And to do that, I add a piece of middleware. I mentioned that this middleware is a pipeline and it's a stack that's growing. So you can actually just put a normal try-catch block in there to catch these common exceptions using my API error class and just handle them. And because these exceptions have the response in, the code's very straightforward. All I have to do is unpack that response, and that's what I send back upstream. That's all I have to do. It makes life very easy. I don't have to write lots of if statements. The middleware doesn't know what business logic has been called. It's given the information it needs to do the job. It makes life really easy. Now there's probably, in Zend Expressive, there's probably a global error handler somewhere that I could be replacing instead, especially with the fact it supports whoops. So there must be some way to bolt one in. But the nice thing about this, again, is remember I said how middleware is isolated from the framework? Whatever they change on that global error handler doesn't affect me. My error handling approach will remain the same, which gives me a lot of, again, it reduces my change surface when there's problems. Sorry, when there's API upgrades. I'm losing it. It gives me isolation when I do framework upgrades. I don't have to change code, that works. In Zend Expressive, there's a piece of middleware which you can replace for handling 404 errors. When someone hits your API and that route is not matched at all, calls a piece of middleware. So I replace that with my own because I want that formatted response. It's my observation, if you send an error back, but the body is empty, there's no body, there's just the headers, people will look at that and wonder what the hell's happened. They won't actually go and look at the headers. They're always expecting to find the information they want in the body. We've almost trained people to do this with the way APIs have evolved over the years. So it's nice to send back a body just saying, 404 not found in this format, so people see it and they don't spend time wondering what's going on. Just a little courtesy thing we can do. Next one's validation. We've got payloads coming in because it's an API, and we're sending payloads out, and we need to do some validation on that. The first thing I do is I adopt a unique content type for every API route. You've probably used APIs where you set the content type to application JSON. Yeah? Problem with that is that it just tells me it will pass a JSON parser. It doesn't tell me what it should be structured as at all. Yeah? I could send any old rubbish as long as it's valid JSON. I don't know what it should be. I've then got to start writing bespoke code to deal with that and validate it. I don't want to do that. We can do better. Have any of you seen this kind of content type, application VND? So if you look in the MIME type standards, you'll see that application VND is reserved for being application-specific content types. So, and the plus is just the separator between them. And so what I can do after that is I can put in there a unique string for every JSON structure that I support. And typically it's a one-to-one relationship between an API and the JSON structure, for example. Because once I've got that, I can then write a JSON schema to validate that data structure. And I did a talk at that down in PHP. PHP Dorset's down even for me because they're down on the south coast in Bournemouth. Yes, being by the seaside when it was 33 degrees, it was a lovely escape from the heat. It's got the cool ocean breeze and plenty of ice cream as well. It's really nice. But I did a whole talk on JSON schema going into a lot of detail. So if you want to know more about that and how to make that work, go watch that talk. But once we've got JSON schema for all our different JSON documents, we can write a piece of middleware to glue all this together. It can use the content type to figure out which JSON schema it should load and validate the input as. And it doesn't need to know anything about the business logic at all. It can just work off the request. And so it can reject the payload before it even hits our controller if it's badly formatted, which saves us a lot of trouble. One piece of code can save us a lot of trouble. And finally, if correctness and robustness are two things that are important to you, something else you can do is you can catch errors that you are causing. Because these APIs have got payloads going out, and they're JSON documents as well, with their own content types. So you can do the same thing here. The same piece of middleware, it sees the responses coming out as well. So it can do the validation for that as well. And if you are shipping bad data, badly formatted responses that don't match what's supposed to happen, you can catch that and know that you've got a problem before your customers do. Or at least you can say, we've found it, we're working on it when the customer phones. It can, it's really good. And JSON schema is fast enough that most of the time you can afford to do this. So I highly recommend that as an approach. I'm really not a fan of using these custom input filter type classes where you end up with a lot of bespoke logic to describe your input structures. JSON schema is a lot easier and you get a lot less defect rate with it. But I cover all that in that JSON talk that I mentioned earlier. We need to talk about authentication. And this one's here because it's bitten me in the arse, I'm afraid. There's no two ways about it. And I'll explain why as we go through. So the first thing you need is something to act as an identity provider. You need something that's going to own the user database, have the website for the user to create accounts, log in, change their passwords, all that sort of thing. And it needs an API that you can call to say, I've got this user, is it really them, yes or no? So it normally has some sort of OAuth 2 support as part of that. If you haven't got one, there's a whole range of people offering this service because it's such a common need. And Auth0 is one of the popular ones, it's one of the market leaders. And I believe they've got a free tier that's quite generous. So if you haven't got one, and it might be easier to use something like this, at least to get you started, than build your own identity provider from scratch. Just a quick tip. Now the reason I'm talking about authentication is cross-origin resource sharing. How many of you have dealt with this? Yeah? So, you're probably aware that the spec for this, which I believe is called the fetch spec, if memory serves, behaves a little differently to how the rest of the web works. There's a handshake before the request is allowed to happen. This handshake is always unauthenticated. You cannot make it be authenticated. Which means if you're used to securing your APIs by having a HT password file and using HTTP basic auth at Apache or Nginx so that you don't have to worry about it inside your app, you're screwed, I'm afraid. And this is what has bitten my arse. Your app, unfortunately, has to do authentication after you've done all the calls and negotiation. If there's a way around it, please tell me, because this one's a pain in the backside. But that's how the spec's designed to work. So if you've got an API that's going to be called by people writing JavaScript that runs in browsers, and I wouldn't be surprised to find there are other execution contexts where it also does calls, you've got to handle authentication inside your API. You can't offload it to something else because it has to happen after the calls negotiation has happened, unfortunately. And the reason this is important is, I don't know what things are like around here, but where I do a lot of my business and I talk to a lot of my peers, JavaScript tends to be more and more what's calling APIs. The days of having back office systems that are invisible to the outside world are disappearing. It's quite common when I go into a client, they've got lots of JavaScript developers because they're doing a lot of front-end work all the time who could come and call an API today. They could start work today once they've signed the deal. If they had to be talking to their own back-end system first for it to talk to another back-end system, they don't have those people. All those people are far away and require extra budgets, etc., and projects have to be raised. And it becomes a reason that projects don't get happen and deals don't get signed. So it's more and more important that APIs just work from browsers these days. And of course, then you've got better data privacy laws. In the old days, we could offload authentication and put it at the front and the app didn't need to worry about it. These days, it's really handy to have an audit trail so you know who's done what to the data that you're managing via your API. So it's better just to bite the bullet and support it from day one, even if you think you don't need it. Just get it done. So you end up writing middleware to authenticate and authorize users. I prefer them to be separate. I suspect there's a strong case that I'm wrong with this. But again, I'm after that code isolation. I want to be able to change the identity provider without having to touch other codes. So that's why I prefer them separate. But it may make sense for authentication and authorization to be done in one lump sum for performance. When it comes to authorizing a user, so authentication, very quickly for everyone's benefit, authentication is saying, yes, I know who you are. I recognize you as a user. Authorization is saying, yes, I'm going to let you do this silly thing you're trying to do. That's the difference. If it are two separate stages. I have a very strong opinion about this. OAuth 2 has a concept which I know of as scopes. I don't know if that's the correct term or not. You know when you sign into Facebook or Twitter for an app and it says, here's the list of things it wants to do. So that's a very simple list in the back end basically called scopes. Just a simple list. There's no hierarchy to it. It's just black and white. Yes or no, you're allowed access to it. And I recommend your API works along those lines. Role-based access controls are desirable because they're infinitely flexible. Unfortunately, they're also infinitely slow in practice. I've seen these written in PHP, I've seen them bring APIs to their knees. They don't scale very well. They've got to load a lot of data from the database or wherever you're storing your RBAC scheme in order to work out what's possible. They've then got to do all that processing to work out what the user's trying to do. How does it match? Because an RBAC scheme can have lots of different decision trees it's got to go down. Sometimes it's got to track up and go down others. You can end up burning a lot of CPU. And people get around that by starting to add caches to cache some of this data. And the moment you've got caches inside your app, you're starting to lose your determinism. Yeah? And one of the nice things I like about Zend Expressive, that the only cache is that config cache, and your config, once an app's deployed, doesn't tend to change. So it's a relatively safe cache. Something like RBAC, where you're changing something that's dealing with decisions made on data, is very different. So my strong advice is, if it works for you, great. I won't touch it. Been burned by that too many times. Metrics. I'm not going to say too much about metrics. It's mostly a reminder that you really want to build metrics into your APIs. Does anyone work with sort of metrics at the minute? Graphite, Prometheus, Grafana. Yeah. I would advise don't use Graphite. As someone who has done some very crazy things with Graphite and hacked it to pieces, and I've had a lot of success with it. For production systems these days, Prometheus is the flavour.
Yeah, we're looking at Elasticsearch as well.
What, sorry?
Elasticsearch.
Elasticsearch. I wouldn't use that for these kind of dashboards, to be honest.
I was about to say I'm slightly lost when you're using the word metrics.
Okay.
Meaning, because I don't know any of the things you just mentioned.
No worries.
Metrics.
I will explain. That's not a problem. So, first of all, the big explanation is in the PHP Northwest talk that I did. And again, hopefully the QR code.
My weekend sorted.
Weekend, you're going to be playing these forever, I'm afraid. This is my third talk in 5 weeks. We're churning them out at quite a rate. Every talk's unique. So this is the only time this talk will ever be performed live. So it's an exclusive for you guys. Yeah. If I'm lucky enough to speak at Scotland PHP, hint, hint, Danny. No pressure. Those talks will be unique as well. I never repeat a talk. Okay. So that will give you the long spiel of it. The thing is with metrics is at the minute it's not unusual that not most of you haven't done much with them. And as a result, there's no PSR standard interface for metrics clients today. Maybe I should get involved and do something about that, because that's something I feel passionately about. I don't know. So you're going to need to find a metrics client. So what this is a piece of code that you're going to call, and it's going to send messages off to the infrastructure that's going to keep track of all these metrics. That's what it's going to do. And you're going to dump that in the DI container. So you're not really going to do anything with middleware here. And it's in the DI container because what you're doing with metrics is you're instrumenting your code. You know how with Formula 1 they've got all this telemetrics? Telemetry, thank you very much. They've got all this telemetry about how the car's doing, and they know all the like pressure on the tyres and braking forces, and they've got thousands and thousands of figures being beamed out in real time. Same idea, but for your app. They tend to break down into timers and counters. Other libraries, especially for app servers, will tend to support up to 5 different types of metrics. But for PHP, because we don't have that persistence, that app server persistence, timers and metrics tend to be the two things, timers and counters tend to be the two metrics we care about. A timer just says something took a certain length of time, and a counter is saying something happened. You normally just send a 1 out. And what happens is they're all collated in some central infrastructure, and they're all added together, they're all aggregated. So if you're running, so if you've got 1,000 users coming in, you'll see like 1,000 users have logged on. But individually, the app has said 1 user has logged on. It's just happened 1,000 times. It gives you real-time insight into what your app's doing. I say real-time, it normally lags by about a minute. You can modify Graphite to do per-second stuff. You've got to throw a fair bit of hardware at it for it to keep up with that, but you can do it, and you can have some fun with that. You really can. Now, the last thing I want to say about metrics, it's quite common for frameworks, whether it's middleware or everything else, to have this thing to say, for them to calculate for themselves how long a request took. That number is bollocks. It's absolute rubbish. Don't use it. Because there's a lot of code executes before that timer starts, and there's a lot of code executes after that timer starts, because you've got that framework with all its pipeline in. So if you're doing this in middleware, you can't account for any of that overhead at all. So that number is misleading. You can look like everything's going fast with your app, but your users still want to throttle you for how slow it is. There's a better way. Nginx and Apache can be reconfigured to put this information in the logs. So you can get this timing metrics from Apache and Nginx, and that number's much more accurate because they're seeing what's actually on the wire. They know when they sent you the first byte of the request, they know when they got the last byte of the response back. That number is much more accurate and a much truer representation of what's going on. Use that number. Do not use anything generated in PHP land. I think this is the final one I want to talk about, which is rate limiting. I don't see a lot of people talk about rate limiting when it comes to APIs. I don't know if that's because their APIs just don't get heavy use, or whether it's just taken for granted. I don't know. But if you think about users on an API, the usage isn't even. You can have some power users and a lot of users who use the API relatively infrequently. And those power users can overwhelm your API and starve everyone else out. So you want to protect everybody from these people. Or at the very least, upsell them enough to pay for the extra infrastructure required. Okay, so you want to put a rate limiting. Now, a common approach is to give them so many requests over a time period, like so many requests per hour, so many requests per day or per month. That's a common approach with that. I'm sure there's other approaches, but that's, most APIs that have rate limits that you'll have used, commercial ones, they'll have something like that. A classic example of that is the GitHub API that Composer uses to download packages. Most of you will have had to generate your own API keys and store it in Composer's config. Yeah, have you hit that? You haven't. Okay. I'm surprised, given the frameworks you're using and how much they download. There is a rate limit built into GitHub, and one of the ways you get the rate limit increased is to have an API token that Composer can send to identify you. So it's not an anonymous thing. That's one of the things GitHub does. So in order to build rate limiting, you need that identity provider again, because you need to know whose allowance you're going to dock, basically. So you need that identity provider. So authentication is needed these days more and more. You need somewhere to keep track of how this is being used. And I'm going to recommend Redis every time. Don't store it in the database. Please don't store it in RAM or on disk. Use something that's built for this job, and Redis is superb at this. Because what you want are what's called atomic operations. Because if you want to send a request to Redis to say, okay, whatever their allowance is, dock it by 5 or 10 or however they're charging for that particular API. And if a heavy user is going to be having 10, 50 requests coming in all at once, and you want all those numbers to be, you want to make sure that allowance is docked correctly all the time, and that's what atomic operation gives you. If you haven't got atomic operations, you get a race condition where some of these numbers can get missed. And so people can use more than their allowance, which may or may not be a bad thing depending on your circumstances, but in general it's a bad thing. And the other reason you use something external like Redis is if you're using autoscaling infrastructure, which I'm going to touch on at the end of this section, you've of that central store tracking everything, so you can run as many instances of your API as you need. You can scale out horizontally, which is part of the things that makes PHP superb over app servers. Now, to glue all this together, you can chuck all this into a piece of middleware. That just calls out to Redis, decrement it, and if the allowance is used up, tell them, sorry, we're not accepting your API request, go away. It's very handy for that. And as I mentioned before, the middleware also sees responses coming back, and it can mutate those responses. So a common thing is, you can actually put little headers into HTTP response to say, you've got so much API rate limit left. And you can tell them how much you've charged them for that particular API call as well. And that can be helpful for developers to see that information. So that's something else you can do. Now, you're going to want to top up these allowances after the hour or the day or whatever it is. So that's a scheduled job. So use Cron for this. It's a scheduled task. Use Cron, or if you're using Kubernetes for your infrastructure, use a scheduled job, or use something like Rundeck. But that's how you should do that. And it just calls in and just resets them back up to their limit. Whatever you do, don't do what WordPress did and build a cron system inside your app. Don't do that. The reason why you shouldn't do that is there's nothing worse than calling an API and having it stutter because it's gone, oh, there's been 100 requests, I now need to go off and do this other thing that's completely unrelated to your API request. I've got to do all these scheduled tasks, and then I'm going to come back and respond to you, which is how these built-in cron systems work. Yeah? They have to be triggered by an end user. Also, if your site's dead overnight and no one's calling it, it doesn't get executed. How many WordPress sites have a cron job whose job is just to call the cron system inside WordPress to make sure things happen?
That's in the documentation thing, they've actually said that we've got a cron job for the work.
Yeah. So, don't do it. Use a proper cron job, schedule service, Rundeck, something that's built for it.
Was that not, they did that based on the assumption that the majority of their users were on shared hosting and obviously wouldn't have access, or wouldn't be guaranteed to have access to the cron job?
I'm absolutely sure that's why they did it.
And it was like, but it's not the point, it's still not a cron job.
In this day and age, for building APIs, would you put it on shared hosting?
Well,
you wouldn't, because shared hosting is too insecure. You can't secure a PHP app on shared hosting. That's why we have containers, it's why we have virtual machines, it's why we have cloud infrastructure. So use the real thing. Auto-scaling. Do you all know what auto-scaling is? Auto-scaling infrastructure? Anyone doesn't? Right. So in the old days, in order to deal with this surge of traffic, we had to have the right number of physical servers in a rack in a data center somewhere. And they all had to be pre-provisioned and active all the time. So no matter what the peak of traffic was, we didn't run out of CPU or RAM or network ports or whatever we needed. That's what we used to have to do. Bloody expensive. Back in the mid-2000s, your infrastructure and hardware budget was often the largest single cost on a project, not the time it took to develop the software and ship the software. It used to be your infrastructure. Those days have changed thanks to cloud computing, which is all running virtual machines and containers, depending on what you're using. And what they will do is they will spin up new virtual machines on demand. They'll look at the load, and you can put parameters in there to say, well, I want this much in the pool, I'm willing to spend this much money to cope with the extra demand, and it will do it all for you. It's called auto-scaling. And you need it because per user rate limits alone aren't going to stop your infrastructure from melting. Because if all your users pile in at the same time, they'll still overwhelm the system. Because a lot of people forget, when people talk about successful websites, they'll talk about like 5 visitors per second or so many API requests per second as the headline figure. GovUK said recently, last year, said that we worked out 7 requests per second, something like that, for example, to show how big they were as a website. But the problem is most of us sleep at night. We tend to work in 8 or 6 or 4 hour chunks. You have peaks and troughs. So auto-scaling infrastructure is your friend for this, because it stops you having to have all this physical hardware all the time, and it stops your users getting fed up because at busy times nothing can happen. That's the thing for that. So these are all things you need to drop into your Zend Expressive app once you've created the skeleton and started altering the structure to suit yourself. And Zend Expressive out the box doesn't do any of these for you. You've got to do them all yourself.